Okay, so you already done this, okay? D-finite integration. So now we're going to learn, actually this one is application of integration, that is to find the area under the curve and also the volume, right? So but today we're going to cover how to determine the area of the region, right? Okay, so the first thing is the theory part, okay? So the theory part is how this formula is, how to get this formula. So area under the graph is, okay, and the graph from A to B, okay, A to B. So area under graph for the curve and the y-axis is given with this formula, right? So area under the graph for, if I give you, simplify it, so this is the curve, then this is the area from A to B. This is y equals to fx. So we integrate y with respect to dx with respect to x from A to B. That is the area under the graph. This is the area, right? If we want to find the area under the graph with the curve and the y-axis, so if I give you another one, is like this. So I want to find the area of the curve with the y-axis, then I have, let's say here is C to D. So I integrate C to D for x dy. So you can see here the difference. This one dx, if the area we want to find is under the graph and between the graph, the curve and the x-axis, then we integrate y with respect to x. If we want to find the area, the curve under the curve and the y-axis, then x dy. So you must know this formula, okay? And then how to get this formula? So is, as you know, just to explain briefly, yeah? So I want to find the area of the curve. Actually, the area of the curve, you are unable to find it exactly, right? So we need to make the area very, very small, okay? Very, very small. So meaning that if I do like this, very small, very, very small, and then another one nearby, I use red, very small also, okay? It's actually is a rectangle, okay? It's a rectangle. So you can see here, there are two areas beside. One is the black, okay, the other one is the red. So the red will be maybe higher a bit from the black one, okay, a bit only, right? That's why it's delta x. Delta x means it's a small change, okay, a small change. So this is delta x and this is y. So y times delta x. Therefore, when you add all together, okay, we sum it, right? We sum from n, okay, and I equals to 1. That means from the first one, here is y1, y2, y3, and then yn. So you add it all together. So therefore, we use this formula y1 dx. Okay, sorry, not dx. Is delta x, very small change. So this is, okay, this is delta x, okay? Then we sum it from, okay, so again, sorry. So we find the limit, okay? Remember, limit delta x, very small, okay? Meaning that delta x is very, very small, and when you add it together, then it become the formula from A to B, y dx. This is a very simple explanation, okay? Right, so meaning that a curve can be break into very small, tiny strip, okay, very tiny strip in the shape of rectangle. And then this tiny strip is because where the delta x is very, very small. Okay, so very small. That's why the limit when delta x very, very small, you add all the area together, it will be almost approximate to the integration from a to b y dx, or integration from c to d x dy. Okay, this is a formula lah. So the formula is this. Okay, either fx dx or y dx, or y x dy, or right, x dy or fy dy. Okay, so and then one more thing you need to know, the value of the area region above x-axis is positive, and the integral value of the area of the region below the x-axis is negative. That's why you can see from here, this graph, if I give you this type of graph, then this part is positive above the x-axis, okay, above the x-axis or positive, okay, above, okay, this is x-axis, so above is positive, below is negative, so negative I use red, so positive, positive, negative. If I want to find the area of the shaded region, area of this shaded region, so I integrate a to b, and then c to d, okay, b to c, right, b to c, so I need to modulus it because this part is negative, okay, so this is positive, negative, positive, so I think this one, there's something wrong here, should be a, b, b, c, c, d connecting, so this one a, b, please do correction here, okay, so this is a, b, okay, again, this one is a to b, b to c, c to d, so this one is positive, this one is negative, positive, so you have to separate it into three parts, okay, so you cannot combine it. If you combine it, the area will be less than expecting, okay, so area above is positive, positive, and area below is negative. Okay, let's find, okay, how to find the area of the shaded region. Example given, right? So this one is area of the curve and bounded by the area of the curve and also x-axis from -2 to 1. So it's actually this part, so area of the shaded region. So we use the formula A equals to A to B y dx. So this is y. So we substitute in. So -2, 1, 3x squared plus 2 dx. So we integrate as usual. Okay, we integrate as usual. So we integrate. So 3x squared become 3x cubed over 3 plus 2x from 1 to -2 to 1. Okay. Okay, then this one you'll get x cubed, right? So now I can substitute in. So 1 cubed plus 2 times 1. Then you minus -2 cubed plus 2 minus -3. So you use your calculator, you should get your answer here, all right? So you also can use your calculator straight away to find out, but you won't get a full mark if like that. So 3x squared plus 2. So what is your answer? Okay. So you should get the answer is 45 here. Okay, so 1 cube plus 2 times 1 is 3. Okay, sorry. And then -2 cube, -8. On. Let me check. Sorry, this one is -2. Why 45? Huh? Okay, sorry. I think I pressed wrongly. So it's 15. Sorry about that. So this one is 15, right? So 15. Huh? So 3 plus 8 plus 4, right? 3 plus 8 plus 4. So it's 15. Huh? Okay, correct. All right, so next question. Okay. So find the area bounded by the curve and the x-axis. So now you can see the area is under the graph. Okay, so remember, if this type of question come out, very simple question, you get the value is negative, but when you answer the area of the shaded region, you just change it into positive. Okay. All right. Oops. All right. So here, the A will be from 0 to 4 and y dx. So 4 to 0, y is x times x minus 4 dx. So you just expand this one is x squared minus 4x dx. So what is your A? So A will be, we integrate x cubed over 3 minus 2x squared from 0 to 4. So you substitute in. So it's 4 cubed over 3 minus 2 times 4 square, and then you minus 0. Okay, so no need to write. So what is your answer? So you find it out by yourself. Okay, so this is the area of the shaded region. You should get a negative value here, right? So negative, so you put it positive. So remember, if this is the area under the graph, right? So you must put a modulus here. Okay, modulus, modulus. So everything modulus. So the answer is modulus. Okay, so okay, let me check the answer. So you get 160 over 3. Okay, you can check by yourself later on. Right? So positive, huh? Remember, positive. Okay. C, okay, you can see here C, the graph of the curve, okay, one in positive, one negative. So this part is positive, this part is negative. So you have to separate the two areas separately. Therefore, our area of the shaded region will have two parts. One is negative 3 to 3, 9 minus x squared dx. And then you have to plus modulus from 3 to 4, right? And then 9 minus x squared. Okay. Okay. All right. Sorry. What you do? Okay. So this is dx. All right. So remember to separate into two. This part is modulus, because this one negative. All right. This one is negative. This one is positive. This part positive. So you have to separate into two areas. So area A and area B. All right. So remember the formula for area is A to B, y dx. Okay, so we integrate. So it's 9x minus x cubed over 3. So from negative 3 to 3, then plus modulus, same thing, 9x minus x cubed over 3 from 3 to 4. Okay, So you can do it now. So what is your answer? All right, so substitute in. So remember in the exam, this one no marks. You need to substitute in. That means 9 times 3 plus 3 cubed over 3 minus 9 times negative 3 minus negative 3 cubed over 3 bracket. Okay, this one, then you have one, the marks here. This part got marks. Then you plus and then modulus, remember. So 4 to 3, so 9 to 4 minus 4 cubed over 3. Then you minus 3, right? 9, 3, 27 plus minus 27 over 3. Okay, so you get your answer. Right, I think should be correct. 9 minus x squared. Okay, 9 minus x squared. Okay. All right, so check your answer by yourself. I also check my answer. Right. So your last answer must be 118 over 3, right? 118 over 3. Okay. So you can check by yourself. Okay. So now the next one also the same. Okay. You can try to do this question. All right. So there are two parts, negative, positive. So from negative 2 to 0, 0 to 1. So your area will be A plus B, right? So this is A, this is B. So A will be modulus from negative 2 to 0, x cubed dx. Modulus, and then this part no need, 0 to 1, x cubed dx. Okay, so this part you get modulus, okay, x to the power 4 over 4, 0, negative 2, plus modulus, this one is from x cubed over 4, 1, 0 to 1. Okay, so you get here 4 plus 1 over 4. So the answer is 5 over 4. Okay, so 2 cubed, 2 to the power 4 is 16. 16 divided by 4. So is negative 16 divided by 4 is 4, right? So it's negative 4. Okay, so negative 4. So negative 4, you modulus it, it becomes positive 4. Then you plus 1 over 4 minus 0 over 4. So you get 4 plus 1 over 4 is 5 over 4. Okay. This is C and D. So now we go to the next one. Okay, this is a bit of application. So diagram shows a curve y equal to fx like this. The shaded region is defined from A to B, fx dx. Find the value of A and B. So the shaded region is A, this is fx. So we just apply the formula. So what is A and B? So from here you can see A and B is negative 1 and 5. So number 1, the answer A is lower limit, so negative 1. B is the upper limit, so it's 5. So this is upper limit, lower limit. So what is upper limit? This is lower limit, upper limit. Okay, the limit means the limit from where to where. Right? From is lower limit to upper limit, where to where. Right? So number 2 is given the area bounded by the fx axis negative 1 to 9 is 12. So this A plus B is 12. So what is the value 95 fx dx? Okay, so B, the area will be 12 minus okay. What is the area of the shaded region? Is that the value? So I think the question not complete, right? Is that the value? 9 to 5. Okay. Oh. Okay, so I think okay, the question didn't give you the value of this one, right? So maybe we just write as the shaded region is defined as here is 5 lah, huh? Okay, so we add in. Therefore, B will be 12 minus 5. So you get 7. So the area of this area is 7. So therefore, the value 5 to 9 fx dx is negative 7. Must be negative because we are finding the value of integration from 5 to 9 fx dx. So it should be negative 7. The area, total area is 12, right? So here we add in the area, the shaded region is defined as PA fx dx equals to 5. All right, so 5. That means here the area is 5, so here must be 7. Right, so here must be 7. Okay, so here is 5. Oops, so big. Okay, so here is 5. So here is 7. So, but the value here is negative 7. Okay, so the value here must be negative 7. All right, so there are 3 marks here. So understand, huh? So this one you add it by yourself. So here equals to 5. Okay, so this part is 5 units. So unit square, this part is must be 7 because total is 12. From negative 1 to 9, if 12 units square. Okay. Okay, the next one. Okay, that's now already explained. Area between the curve and the y-axis. Okay, so with the Balek, the formula that is from A to B, x dy. Okay, and same goes with the area. So this time the area on the right is positive, the area on the left is negative. Okay, okay, so you can see here the area here positive, right and left, right? This is right, this is left. On the right is positive, on the left is negative. Okay, so when you want to add these two together, find the area of this total area. So you must add A to B, modulus, B to C, modulus. Okay, modulus means everything inside is positive. Right, so find the area. All right, find the area of each of the shaded region. Okay, so let's do it. Okay, so from 1 to 3, okay, so the formula is A equals to A to B x dy. So now we have y equals to square root x minus 2. So y equals to square root x minus 2. So what we do, we have to square both sides. So you get y squared equals to x minus 2. So x equals to y squared plus 2. So therefore, now I can find my area. The blue area is from 1 to 3. So x dy. So therefore is equivalent to 1 to 3 y squared plus 2 dy. Okay. Right. So I'll do it this side. So therefore our A is 1 to 3. Sorry. Is it 1 to 3? So right. 1 to 3 y squared plus 2 dy. Okay. So equivalent to, okay, you integrate. So you get y cubed over 3 plus 2y. So you integrate 1 to 3. So you will get 3 cubed over 3 plus 2 times 3 minus 1 over 3 plus 2. Okay, so you get your answer here. Right? Okay. Then we go to B. Okay, B is find the area of the shaded region from 0 to 1 when y equals to x to the power 1, the quartered root of x. So meaning that y is x to the power 1 over 4. So what is x? X is y to the power of 4. All right. So now I can find my area. So my area will be A equals to 0 to 1 y to the power of 4 dy. Therefore, I have y to the power of 5 over 5, 0 to 1. Therefore, my answer is 1 over 5. This area is 1 over 5. Okay, so remember to change x, the subject y, into x when you want to integrate from the area under the curve and the area bounded by the curve and the y-axis. Okay. So now we go to C. Okay, C how to do. So C is y equal to x plus x over 2 plus 2. So you can see here there are two areas, one positive, one negative, right? Okay. Actually, this question you can use area bounded by the x-axis and the curve, right? But it's quite difficult to do like that, right? So this one better. So you can from 0 to 2, 2 to 4, right? Easier, okay? Because the area of the shaded region is very clear here, these two parts, right? Right, so here you see, this part will be 2 to 4 x dy. Then this part will be 0 to 2, 0 to 2 x dy. But this one must be modulus, okay? So the area of the shaded region. So what is x? So this one we need to change first. So our x is, so you multiply 2 first. So you get 2y equals to x plus 4. Therefore, our x equals to 2y minus 4, right? Now I can start to integrate. So from 0 to 2, 2y minus 4. dy plus integrate 2 to 4, 2y minus 4 dy. Okay, equals, okay, so you integrate, so you get y squared minus 4y, 2 to 0, plus, okay, y squared minus 4y from 4 to 2, okay? So you should get your answer. All right, so this one, 2 square is 4, 4 minus 8 is negative 4, so here is 4, then plus 2 square, 4 square minus 4, is 0, then right, this one is 4 square minus 4 times 4. So it's actually 4 square minus 4 square. Then you minus 2 square minus 2 times 4. So it's negative, negative, positive. So this part is 0. This one is 4. Right? So negative 4. So therefore the answer is 8. Okay? The 8. So this one is 4 unit, 4 unit square, 4 unit square. So 8 unit square altogether. Then we go to D. Okay, D, we want to find the area of the shaded region here. So remember, we need to change y minus 1 square. Okay, so y minus 1 square equals to x minus 1. So we need to change x equal to y minus 1 square minus 1. Okay, so you can expand this. So become y cube. Sorry, y cube. Crazy already. Stupid teacher already. Y square minus 2y plus 1 minus 1. So we will get y square minus 2y. Right? Okay. So now I can integrate. Therefore, our a is from 0 to 1, y square minus 2y dy. Okay. So you get y cubed over 3 minus 2y square over 2, 1, 0. So you can get the answer yourself. Okay. Sorry. Okay, this one is plus. Sorry, plus. Therefore, it's plus 2, right? So, okay, everything wrong again. Yeah. No wonder the answer is incorrect. So here is plus 2 dy. Okay, so here I rub off. So you get plus 2y. Okay, from 1 to 0. Therefore, I have to plus another 2. So the answer will be correct now. So 2 my 1 plus 1 over 3. So it's 4 over 3. So this part is 4 over 3 unit square. So this is how you find the area of the shaded region. Okay, now this question. Okay, ignore this, sorry. Okay, given that the diagram is from 0, B, A. So what is the value of A and B? So this is the y-intercept, right? Y-intercept. So how to find y-intercept? When x is 0, number one. Okay, so I want to find y-intercept. Okay, x must be 0. Therefore, y times y minus 1 times y minus 3 equals to 0. Therefore, I have y equal to 0 or 1 or 3. Therefore, B is 1, A is 3. Okay, so B is 1, A is 3. Okay, so find the area bounded by x equal to y times y minus 1. So meaning that we want to find the area from 0 to B, right? This area. So remember, this is positive, this is negative. So the area is from 0 to 1. So this one this one later on x dy, and then you plus modulus from 1 to 3 x dy. Okay, so this one you expand, so you get y cubed. Okay, y cubed. So minus 4y squared plus 3y. Okay, so dy. So how to get? You try by yourself. You go and multiply lah. Okay, and then this one. All right, so okay, so you can do it by yourself. So you get y to the power 4 over 4 plus 4 over 3 y cubed plus 3 over 2 y squared from 0 to 1, and then you plus modulus same. Okay, when you get this. From 1 to 3. So you should get your answer later on. All right, so after you simplify, you have to after you integrate, so you need to substitute the value in, then you get your marks here, right? So meaning that here 1 mark, here 1 mark, answer this one 1 mark, the answer 1 mark. Okay, so that's how you get marks. So you substitute in 3 cube, right? 3 to the power 4 over 4 plus 4 over 3, 3 cube plus 3 over 2, 3 square, and then minus 1 over 4 plus 3 over 4 plus 3 over 2. Okay, so you add it together. Okay, this one is, oh sorry, this is this part, right? So modulus it. So there's another one here you need to substitute in. Okay, so you'll get your answer here. So I don't tell you the answer, you find it by yourself. All right, so now we go to the next one. Okay, or for area, to find the area of the under the curve, there are 3 parts. Okay, actually there are 3. So that's mean area bounded by the curve and the x-axis, or the area bounded the curve by the y-axis and the y-axis. And also how to find the area between a curve and a straight line, and between 2 curves. Okay, so if I want to find, there are 4 situations here. If I want to find the area of the shaded between a curve and a straight line, so you want to determine whether the straight line is below or above. So if the curve is above, the curve is above the straight line, therefore we use this formula from A to B, fx minus gx. Why this formula? Okay, because fx is actually, fx is actually, if you see the graph, fx is going up, the whole thing here, right? This is fx. Okay, so this is area from A to B dx. And then you minus the area of this. So this is gx. Okay, you minus this minus this, you get this area. So this area will be A to B fx minus gx dx. Okay, but not every question you got to minus. So you can see the second situation, right? So it's a straight line and a curve, but now we want to find from A, B to C, right? So A and B, so you can see B to C is area under the curve, but A to B is area under the straight line. So we add these two together. So A to B, we use the equation of the straight line, and then B to C, we use the equation of the area under the curve of fx, right? So meaning that this will be this part plus this. So this is the curve, this is a straight line. Okay, so this is G, this is F, right? So you can see it. So if I want to find in terms of y, so this one, so I use Fy, the curve, minus Gy. Okay, meaning okay, so it's this side. So you minus this part. So you equivalent to area of this. Okay, this is the area. Okay, so above, so meaning that this one, if you want to make it short, is above minus below. You've got side to side, then you add together, right? Side to side. Okay, side to side, that is the curve plus the straight line. Okay, so this is the fourth situation. Okay, right, and then one more, the equation of the curve between two curves. So we just use the formula fx minus gx. Okay, so regardless of okay, let's say I have this information. If I have two curves like this, okay, so I want to find this area from A to B. So I know this is fx, this one is gx. So I use the formula A to B. So above minus below. So above, remember, above minus below. Above, this is above, this is below. So be careful. So this one is G x minus f x dx. Okay, so this one. Okay, if the curve is one on top, okay, so let me give you a very brief. So I have two straight lines. So one is f, the other one is g. So I want to find the area between these two areas. Okay, both are straight line, I know, but easier to explain. So I use also the same formula, fx minus gx from, let's say this is A to B. All right, so why like that? Because when you do fx gx, this part is here, this part is here, negative. So negative, negative, you get positive. And then this one, it will be gx will be here. Okay, you can see here. And then fx will be here. So you minus these two areas. So you will get, right, this one is this, the area in the middle. So you use the same formula. Okay, regardless, the curve is both one up above the x-axis, the other one is below the x-axis. You also can use this formula. Both at the same axis, above but above the x-axis, then you use the same formula also. Okay, one above, one below the x-axis, you also use the same formula. Right? So this one is the same. Okay. All right. So this one is one like this, but this one is fy gy. Okay. So same formula. Okay.